Hello and welcome to the lecture on operating system. So we are in the topic of paging, which is a non-contiguous memory allocation strategy, in which we have learned that how the whole process is divided into number of pages, and these number of pages will be allocated into the physical memory in terms of different frames. There is a frames, and frame has a size, and the frame size and the page size will be the same. Now here we have seen that how we can translate the logical address to the physical address. So the logical address is the address generated by the CPU for the instruction, and the physical address is the address for the physical memory where the instruction is stored. So here what will happen is we have the CPU, whatever address it is generating, it is in the form of bits. So how many bits it is generating, it is divided into two parts. One is the page number, another is the page offset. So the from page number will go to the page table to find out the frame number, and from there we'll find out the frame number, and the page offset is directly given to the frame offset, and then we'll calculate where is the particular word that is required by the CPU. Okay. So this is how it will be done. So we have this page table, and the page table, if you want to calculate the size of the page table. So if let's say there is a page table size, so it will be uh, the number of pages in the page table. So we have number of pages, right? And what is the each entry size? So this is how we can calculate the page table size. How we'll calculate the number of pages? So the number of pages will be calculated as there is a uh, logical address space. So we have the logical address space, and it will be divided into what is the size of each pages. So page size. So what is the size of the page? Depend upon that, we'll get number of pages, and number of pages, we have the entries on each pages, right? So one page, one entry, another page, another. In that way, we'll get the page table size. This logical address, if you want to calculate the logical address space, it will be from the logical address. Let's say logical address, I want to calculate the logical address space. The logical address is given, so the logical address space will be 2 to the power of logical address, right? Whatever is given. Or if I want to have the logical address space, I want to calculate the logical address. So how I can calculate the logical address? It will be the upper bound or the ceiling value of log base 2 logical address space. So I'll get this logical address from that. The same thing will happen to the frame size also, right? So if I want to find out the number of frames, so how will find out the number of frames? So the number of frame will be, let's say, m, and m will be calculated as a physical address space divided by frame size. So what is the frame size we have? And the same thing will happen to the physical address space also. If the physical address is given, so we can find out the physical address space by 2 to the power of physical address. And if I want to find out the physical address with physical address space, so it will be upper bound of log of 2 physical address space, right? So these are the thing that we have to remember while doing these type of calculations in the paging. So paging is a technique which will help to calculate the logical address generated by the CPU to converting into the physical address, and so that we can get the particular word that is required by the CPU or particular byte required by the CPU. of the instruction. Okay, let's see in a practical way that how it look like. So if you have the physical address, see this is the physical address given, right? So physical address is 12 byte. Then the physical address space will be, so what I told you, if the physical address is given, what is a physical, if physical address is given, so what is a physical address space? Physical address space is nothing but 2 to the power of physical address. So here, what is physical address is 12 byte. So it will be 2 to the power of 12. So it is nothing but 2 to the power of 2 into 2 to the power of 10. So 2 to the power of 10 it will become k, and 2 to the power of 2 will become 4. So it will be 4k, which is already written here, right? 4k words. So this is about physical address. Physical address, and physical address is for the main memory, or you can say for the frames, right? Physical address is for the main memory, or you can say frames. Now the next it is given is logical address. So logical address is for the instruction generated by the CPU. Logical address 13-bit, and the logical address space will be 8k. How 8k is coming? If the logical address is given, we can calculate the logical address space by 2 to the power of logical address. So what is a logical address? Logical address is 13 byte, 13 bit. So 2 to the power of 13 will be 2 to the power of 3 into 2 to the power of 10. 2 to the power of 10 will be k, right? It will be k. 2 to the power of 3 will be 8. So it will be 8k. So it is showing the 8k is the whole size of the process, right? So this is the logical address space that has been generated. And this is for the page table, or the pages. It's for the pages. And it will be useful for the page table and all. Now here it is giving some more thing, that is page size, which is equal to frame size, which is equal to 1k words. So see here it is written the minimum page size will be 1k words. So 1000 words could be accommodated in one frame. Now this is the physical memory. Here we have one frame. In one frame, thousand of what words could be there. So in one frame there is a 1k words. So this is the size of it, 1k. So 1k is the size. Okay, 1k word or 1k byte you can say. So because one word is equal to 1 byte, right? Because we are talking about byte addressable. It is also called word. So we can say that 1kb, 1kb we can say. This is the size of the frame size. So one frame has a size of 1kb or 1k words. Now, we'll calculate the number of frames. So how we can calculate number of frame? Number of frame will be calculated as m. Okay, so how many number of frames will be there? That will be calculated as m, which is physical address space divided by frame size. So that we have seen in here, right? So what is m? M is nothing but the frame, number of frames. So number of frame will be physical address space divided by frame size. So it will be physical address space is 4k, and the frame size, what is the frame size? So frame size is written here 1k. So it will be 4, it will be 2 to the power of 2. It means we have 4 number of frames. So as you can see, 0, 1, 2, 3, 4 number of frames are there in the physical memory, right? Now we'll calculate the pages, number of pages. So it will be calculated as n. That is logical address space, which is LAS, divided by page size. Page size is what? 1k. And logical address space, as you can see here, it is 8k. So how much? It will be 8, which is 2 to the power of 3. Why we have written 2 and 3 here? These will tell us that these many bits are required to allocate the frames, and these many bits are required to allocate the pages. Okay, that's why. Now it is directly these circled bits are directly telling you what is P and what is F. So because the logical address space has two part, right? Page number and the offset. Hmm? And this physical address is also having two part. What is that? The first part is frame size, frame number, and the second one is the offset. Here, this offset and this offset will be the same. Means whatever bit we are putting here, that will be the same we are giving here, and then the frame will be attached to it, and there is a concatenation, and we'll get the address. Now come to this logical address, which is generated by the CPU. It is of 13 bit. Why it is saying 13 bit? So it, because it is having two part. One is the page number, another is the offset. So what is a page number? Page number is finding out which page it is. So we have 8 number of pages. So to allocate the pages in the binary, so let's say I want the third number of pages. So for that, how many bits are required? So I required 3 bits. Let's say the seventh number of pages. How many bits are required? I required 3 bits, right? So let's say if we are talking about 7 number of pages, so P will be look like this, with the 3 bits. If I am looking for third number of pages, the uh, the 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 P will be look like this. So this is 3, right? So now you assume that here we have 3. So that's why it is putting into 3, right? And from the offset is telling you about the page size of the frame size. So what is the page size of the frame size? Is 1K. For 1K, if you want to find out the bits, how many bits is required is 2 to the power of 10. So this is 10 required. That's why it is of 10 bits. Getting it? So for each word, I required at least 10 bits to locate them. So that's why it is of 10 bits. Here also it is of 10 bits. Why? Because the page size and the frame size will be the same, one byte. So I think you understood. Now here it required 3 byte, right? And let's say my third pages are in, let's say, second frame. So let's say it is in second frame. So how many bit it will be required? It required 2 bit to allocate. To the second bit, this is how we can allocate. And if it required third bit, so it will be this. So because we required maximum of 2 bit to allocate 4 frames, right? And we required 3 bit to locate 8 pages. So that's why here it is 3 and here it is 2. Here it is 3 and here it is 2. So I think you understand most of the thing here in the uh, paging. Now let's try to solve some problems, okay, so that you can fully understand how this mapping will be done and what type of question will be asked.